All right, section 3A is going to be all about percent problems. This section is going to have four subsections in it, so it's a bit of a lengthy one here. But all the stuff that you're going to be learning in here is going to be used for solving things or working out problems in further units, so it's all really important. We want to make sure we do take our time with it. However, the very first section here, what I'm going to call 3A1, is about solving percent problems, and this is more or less a reminder of how you can set up an equation and get an answer for what we're calling here as basic percent problems, and it really is. All right, now there are different ways that you can solve problems. This textbook, and as we go forward throughout like the different units that we do here, we're really going to be using the template that you're going to see in the box. But what I thought I would do here is go ahead and show you at the beginning part in the discussion problem how you could do this using what is called a proportion. Okay, so here's our problem. It says that students examine 140 cars in a school parking lot and find that 15% of the cars in that sample have oil leaks. All right, now the way that they would have gotten that 15% would have been taking the 140 cars that they looked at and also have counted how many cars had oil leaks. And then they would set up a fraction and divide the number of cars with oil leaks by 140. And that comes back as your percent. Now, kind of think about this for a second. The word percent actually means per 100, right? We've already looked at this, that per means to divide. Cent is the prefix for 100, so you're dividing by 100 to get the percentage. Now, what we did is, or what these kids would have done is they would have taken the number that they had and divided by 140, not 100. But when they divide it down by the 140, we can then multiply by 100 and it sets it at a scale of 100. So anyway, the takeaway here is that percent does mean that we're going to be dividing and then you get back your percent at the end. All right, so here's the template. This might explain a little bit better. Whatever that number of cars that had leaks, oil leaks in it, if we divide it by 140, that would be equivalent to 15 out of 100, the per 100 part there. So this is what we call a proportion. That's an alternative way that you can solve problems. You can basically set up two fractions, they're called ratios, and when you set them equal, then you get a proportion. And if you can set things up like this, you can solve for whatever your unknown is by using cross multiplication. So here I know 15 out of 100 has to be equal to something out of 140, all right? And then cross products would tell us that if you multiply the 15 by 140, it's the same thing as 100 times x. I'm not going to get into why all that's true, but it's really easy to verify, and you could go watch some videos on that later. Okay, so for then solving, what we do is we multiply these two, and understanding that their product, 15 and 140, is the same as this product, you can divide the 15 times 140 by the 100, and it finds the x for you, and that's what this part shows. 15 times 140 divided by 100 turns out to be 21. So that would be the number that sits up here. All right, and to fill in the blanks here, you could answer this saying that 21 cars out of the sample of 140 have oil leaks. All right, now there's other versions of percent problems that you can solve, and we're going to see this as we go through the unit here. The x doesn't have to be in that spot. If we knew that 21 cars had oil leaks in there, you could have the 21 over 140 and maybe be looking for the percent over 100, and that could be called your x. Now to get that, you would just divide these numbers in times by 100, or let me imagine this again. If you had an x here, you could multiply these, so you can multiply the 21 by 100, divide that by 140, and it does give you 15%. The x could also be in the bottom, right? We could know that maybe it was 15% of the cars. We could know that 15% was 21 cars, but need to figure out what the total number of cars that were there. And if your x was in that spot, you'd multiply here, divide by 15, and then you'd get that. So it's a template that you can move the x as you need to different spots and still get the answers. The template that the textbook is going to give you also works that way too. Instead of having a total of 4 numbers that mine shows up there, you only have 3 of them because the 100 is kind of just built into this whole thing. You're going to see that part get worked out because when your percents, when you actually set up the problem, you're going to divide that number by 100. You're going to divide like the 15 by 100 and call it 0.15, and that takes care of that. So you get 3 blanks, and any of those blanks could be the x's. All right, the first blank is going to be your percent. you would read like 15% of 140 is 21. Okay, so that middle part is going to be your original amount, your whole value, what we're going to call the reference value for this stuff here. The final answer, what that percentage of this number represents, sometimes we call it the part, sometimes we call it the new value. The word that would go along with like a reference value is what we call the compared value. And sometimes that one confuses me, to be honest, but it is called the compared value, and we'll see that show up. All right, I'm gonna go ahead and skip all the way down to the bottom just to, because we already talked enough about this. You can see where the numbers go. 15% of 140 is, it would have been 21, but what we're trying to do at this time here is start to develop the equation. So they wanted us to put the variable x in. So 15% of 140 is x. All right, next page. Lots of discussion on what the words mean when you say percent of. That does mean multiplication. The word is going to refer to an equal sign, which we have here, and then we get to put it all together as an equation here. The 15% is going to get changed into its decimal form, which is going to be 0.15. So that's the dividing the 100 that I showed in my part at the beginning. That will get multiplied by 140, and it gives you x. So if you multiply these two numbers, you end up with 21. Now going back to my setup, just to show you a comparison, this, you see those numbers being multiplied, but that's a 0.15 instead of a 15. I had 15 times 140, but if I just divide 15 by 100, so if I do the division first, that gives me that decimal form of 0.15 times 140, and you can see that it's basically the same math that's happening. All right, question 3, we now get to look at a different one and just see how all this stuff goes in to their spots again. A survey revealed that 48% of employees take their lunch at work. If there are 200 employees, how many of them take their lunch? So we know the percentage that take their lunch. We don't know the number of people that take their lunch. We do know the total number. So total number in the middle, percentage is going to go on the front. What we're looking for is the x. Change that into an equation, and we get 0.48 multiplied by 200 is going to give us x. That answer turns out to be 96. Okay, and then the last question here, which is always a really good thing to do in any of these problems, is to think about what 48% might be close to, because we are fairly good at percentages. We know general checkmark things like 25% is a fourth, 50% is half, and so on. So 48% is very close to 50%, which is half of this amount, and 96 is actually pretty close to half of 200. It's just short of it. And 48% is just short of 100%. So those ideas go together and make this sound like a good answer. All right, now before I go into the next part of section 3A, what I want to do is mention that x is not always going to be in this spot. I mentioned that at the beginning. I just want to mention it again. We could rephrase the whole setup to this problem and say that a survey revealed that 48% of employees take the lunch to work. If 96 employees take their lunch to work, how many employees are there? Okay, so we can change the wording around. You could have the 48% here, you could have the 96, and then this be your x. And of course, we're going to see some problems that are like that a little bit later. So I don't want to make this seem like everything's going to have x at the bottom, or at the end, sorry, and you're just going to multiply to get those answers. Sometimes if the x is one of those numbers, you're actually going to need to divide to get it. It's still a one-step problem. Use the template, but do division instead of multiplying, and you'll get the answer. All right, so 6A2, this is going to be about percent increase and percent decrease. These are things that happen in our lives almost daily. But the weird thing is the way that we calculate them, I think a lot of people avoid a particular approach that this activity is going to highlight here, and you can get the answers right. It's not that you can't do them, but you seem to do more work because you avoid this little technique that's in here. Okay, so before I do any of the examples here, I'm going to show you, this is like a real thing that I actually do when I go shopping. Okay, now a lot of places, say you're shopping for clothes and you're looking for, I don't know, we'll just do shoes here. The original price of a pair of shoes might be $65, and there might be an advertisement that says that you're going to save 20% off. And a lot of the time they'll actually tell you what the price is that goes with it, but there's also a good number of times that they just quickly put up a sign that just says 20% off. You'll show it marked off when you get to the register. It'll do that. So we're considering, well, how much is that actually going to cost us here? And what a lot of people will end up doing is they'll find the 20% of the 65 and then they'll subtract it from the 65. And that's fine, it works, right? Figure out how much you're going to save in actual dollars, take away from 65. But the way that I actually do this to save calculations when I'm out shopping is I take that base number, we call it the reference value, remember? Take 65 and don't multiply it by 20% what I'm saving. Multiply it by the percent that I'm actually going to have to pay, which is 80%. So if I multiply this by 0.8, then I directly get the cost of this. Now, maybe if I chose a number a little bit better than 65, like $60, I could easily multiply 6 by 8, and remember that's 48. That would give me the answer. The 5's going to throw me off a little bit, but I mean, I could either round up or round down if I wanted, or if I just have a calculator on hand, which is like your phone, take 65, multiply it by 0.8, and that's your cost. It's $52. You can get the same thing as doing 65 times 0.2, which is 13, and then saying 65 minus 13 gives you 52. But it seems to be a longer process. And it'll definitely be a longer process if you're looking at buying a lot of items. So if you're buying a lot of items that are all going to have the same sale price, just take their total and multiply by the 80. Okay, so our discussion problem, I wanted to show both of those versions as well. Let's see here. Health clinic charges $20 to administer a flu shot. Students receive a 25% discount with a valid student ID. So how much does the flu cost with the student discount? Okay, so this part right here I wanted to show is how I think most people will generally do the problem is they'll figure out what 25% is of your reference value, your starting value, and then they subtract it. So we do 0.25 multiplied by 20, tells you $5. The $5 is how much you're going to save. So we subtract that from 20 and we get 15. It's a fair approach at how to do it, and it works. Okay, but you could also do it this way. You could say, if we're getting a 25% discount, why not think of it as how much we're paying, right? 100% minus 25 is 75. And that's easy mental math. Okay, we're paying 75%. So instead, multiply the 0.75 by 20 and it comes back as 15 and you get your price right there. Okay, they don't look much different than each other in how you're going to do the problems, but if you start moving towards doing it this way by figuring out the percent that's actually being applied, your answers are going to come more directly, and I think it's going to ultimately become a bit easier. All right, the rest of this page is really just going to talk about like choosing that other percentage. So there's your reference value. Think of the whole circle as 100%. You're not going to pay a fourth of it, the 25, so you're paying 75. So here's that calculation for 75. Once we get down to the template this textbook is really going to be using, we'd want to read it this way. 75% of $20 is X. X is what we're going to have to pay. So don't use the 25%, say 75% of 20 is what we want. Translate that into the equation. 0.75 times 20 is equal to X. Then just quick multiplication there is going to give you your answer of 15. And of course it did answer or match my answer that I had at the beginning. Okay, percent increase. This is the part where I think it would get a little bit trickier to accept this, so to accept my second idea on how to do the problems. But once you do buy into it, it really does make a big difference. And you're going to see at the bottom of the page, it's going to help you answer some questions that we are going to be asking you. So we're doing it by this method. It's important. All right, for our setup problem, the daycare at a local gym costs $5 per week for members. Non-members' fee is going to be 40% more than the fee of members. Okay, how much does the non-member pay per week for daycare? All right, now the kind of basic approach at this would be to take the 40% as it's given, and that's in decimal form 0.4, multiply it by that reference value, $5, and you get 2. Okay, so 2 is going to tell us the extra amount onto the $5 that the non-members have to pay. So now we got to take the $5, add on the 2, that we found, and it gives you a total of 7. So it's a doable problem. There's nothing wrong with it, but I think it's going to help out if we can start doing this. When we did like the discount problems, what we did is we took that percent and we subtracted it from 100 to find what's left over. In these cases, if you have percent more, the trick is to add that percentage onto 100. So instead of subtracting from 100, just add it onto it. All right, so we take 100%, we add 40, and that means 140. In other words, the non-members, not only are they paying 40% more than what they did, a different way that you can say this is the non-members are paying 140% of the $5. So I can just take this, change it to a decimal, move it forward twice, get 1.4 times that by the 5, and it gives me my direct answer of 7. Now here's a bit of a breakdown on why it works. The 0.4 times the 5 is going to give you the 2 that we saw here. By having that 1 in front of it, the 1 times the 5 gives you the 5. So what it does is it automatically finds the two parts, the 5 and the 2, and it adds them together for you. So it is sort of a time saver, right? I mean, it's still a two-step problem from what we see here, but it's neat to look at it and see how it does like all of it together. It gives you the base amount and it gives you your percentage that goes with it. All right, so 2A all the way through, I think E here are gonna really just do that breakdown again. The reference value is 5. Here's the images that we could use to kind of represent it. You're paying the whole member fee plus a little bit more, plus another 40%. Okay, so that's gonna be the $5 and this will be the $2 that we see in the image. But they really want us to get this part here, that all that shaded region is a total of 140%. It's going beyond one of the circles. Okay, so you want to use the 140%. There's your reference value. We're trying to find the end result of it. So again, we convert it into the decimal, multiply by 5, and you're going to get 7. Same thing that I ended up showing up at the top. Okay. Now these questions, you're going to get a lot of these throughout the rest of the activities here, and then it's going to carry on to some of the other stuff that we do look at later. So we do want to be able to answer these questions. And if you're using the method that's described above here by adding the percentages or subtracting the percentages and then doing the multiplication, these answers come much easier. Okay, so F is really from the prompt. The non-member fee is 40% more than the member fee. That's straight from the prompt. Okay, now look at the change in the wording here. The non-member fee is blank percent of the member fee. Not more than, but of the member's fee. So when we change the wording to there, you want to say 140%. It's the 100% plus the extra 40%. And if you can come up with that number, then moving the decimal forward 2 spots is going to give you the number that fits into this blank, the one that's the times number. The non-member fee is 1.4 times the member fee. So once you can get that percentage, you can change it in decimal form and it's going to allow you to complete that type of a sentence, which I think that this sentence is more what we kind of do in general speaking, like when we're talking to each other. Oh, it's 1.4 times as much. It sounds like a weird number, but when you say that to somebody, I think everybody will understand what we mean. Oh, take the price, times it by 1.4, and it gives you the next price. Okay, so question 3 is going to officially introduce the term percent decrease. Now, we basically did this problem with the flu shot where we took 25% from 100, used 75% and then multiplied, but we're now giving it a title. So most of the stuff you're going to see on the page is pretty much the same breakdown. The X is going to end up in a different spot, which is important to the problem, so we do want to watch that one. And then at the end of the page, we're going to see those 3 blanks that we just did in the last problem, and how choosing it to do it by the method we're now describing is going to be helpful for those. All right, let's see here. Reese is going to buy a t-shirt. He has the 60% off coupons. It's kind of like what I described at the beginning. The new price is $10. So we don't know the old price. What we're looking at is, oh, Reese ended up paying $10 by using a 60% coupon. Okay, now the first thing here is to really understand that the 60% off coupon is something that we should take away from 100. You can use the 60% to figure out the answer to the problem, but it's going to be, in this case, it's actually going to be more challenging because we don't have a reference value. We actually have an end result number. So you really, really do want to go with this method of taking the 60% from the 100, which is shown here, to say Reese paid 40%. Reese paid 40%. Reese also paid $10, which means that the 40% is the $10. Okay, so we don't, it's going to get really odd if you try and use the 60, so you do want to go with that method. All right, so our reference value is X. Just to backtrack, we don't know what the original price was. We know that he's going to pay 40% because of the 60 off, okay, and we know that he paid $10. So once we get down to our template of 3 blanks here, the percent that we want to use is 40. The X is going to be the reference value, the original amount, and the 10 is going to be the amount he paid. And just kind of think how that reads. 40% of X amount is $10. That makes sense. If you try and work the 60 in here somewhere, it's just not going to word right. It's going to be weird. Getting that 40 in there totally sets up the problem now. Okay, so we get to see X now in a new spot, which is here. So this is what our equation would look like. 0.4 in decimal form multiplied by X is going to give us 10. Okay, to solve for X, we are going to undo the multiplying over here. So if you divide both sides by 0.4, it's going to cancel on the left. And 10 divided by 0.4 turns out to be our answer, which I didn't actually finish that one here, so I could show you this one. We're going to do 10 divided by 0.4, and it comes back as 25. Okay, so the original value is $25 to this. I don't think I'll spend the video time to do this, but try and find 60% of that, subtract that amount from the 25, and then you should see that you get $10 out of that one. Okay, now the blanks that you're gonna, I promise you, you're gonna be asked to fill in these types of blanks. So using this method would be pretty helpful. The sale price is 60% less than the original. So that's coming straight from the text, as was told. It's 60% less than the original. The next question is how we want to change our mindset on the problem. The sale price is 40% of the original. So we want to actually get away from the more than, less than type wording and get into the percent of, because that's going to fit our templates, right? Percent of. So we're going to subtract the 60 from 100 and then use the 40. The sale price is 40% of the original. Once you have that number, the percent of number, you can just shift the decimal and it becomes your factor, the number that you want to multiply by. Okay, so the sale price is 0.4 times the original. Okay, again, you're going to have to do these a lot, and really what we want to do is get away from the wording of percent less or percent more by either adding or subtracting to 100%, and then it becomes a percent of. All right, question 4 is going to take us back to a percent increase problem. We've basically been going back and forth between percent decrease, percent increase. The methods are generally the same. So the main purpose of this question is to do a percent increase with the reference value as the X. So it's a lot like number 3, except you're going to be adding 100% versus subtracting from the 100%. So I should probably read the problem real quick. Yoga Studio charges non-members $18 per class. The non-member fee is 50% more than the fee for the members. Okay, so the non-member fee is $18 per class, and the non-member is paying 50% more. So we don't know what the members pay, but we know that 50% onto theirs is going to give us what the non-member pays, which is 18. Okay, so it is important at the beginning that we really think about what numbers do we have? Do we have the reference value or do we have the compared value situation? What we have here is what we're missing is the reference number. So we don't know the X. Here's that graphic again. The non-member fee, they're going to be paying the member fee plus the increase on there because it's 50% more than. So what we want to start off with the beginning is taking 100 and adding 50 to get 150%. That's the percent of that we want to use. Okay, moving down into our template, 150% of the member fee that we don't know is the non-member fee, $18. Okay, all right, so then changing into equation, decimal is going to move forward twice. You're going to get 1.5 multiplied by X gives you 18. So to solve this, we'll be dividing by 1.8. Let's see what that looks like. 18 divided by 1.5 is going to give you 12. So it cancels out here, and then that evaluates as 12. Okay, so the member fee will be $12 there, and this one's kind of an easy one to break down. So if the member fee is $12, 50% of the member fee is 6, and if you add 6 onto 12, you get 18 in there. Okay, so again, what we're looking for is, where is it at? We are looking for the more than, the percent more than, or the percent less than, and we want to change those, okay, into a percent of. All right, so these questions here, the non-member fee is blank more than the member fee. That one, I kind of thought it was odd that they put it there, and I went ahead and erased my answer because I wanted to put in that 50%, but this is actually that final answer. So it makes more sense to go through these first. The non-member fee is 50% more than the member fee, so that's the one that's straight from the sentences, straight from the prompt. All right, then we want to change it into a percent of by adding on 100% because it's a more than situation. So the non-member fee is 150% of the member fee. That then, shifting the decimal, gives you the number you want to multiply by, which is 1.5. Okay, the non-member fee is 1.5 times the member fee. From that point, you would need to set up some sort of an equation because this is a solving problem. You don't actually just multiply and you're done because you have the end result. You've got the $18, $18 and you want to divide that by the 1.5. Now that that's all done, we found out that the non-member fee is $12. We can actually complete this blank. The non-member fee is blank dollars more than the member fee. Member fee is $12, non-member is 18, so it's actually $6 more. Okay, so odd placement of that question. Probably should have gone at the end there, but no real harm in it because think of this as a summary, so you already found that answer in a way to do that. All right, problems 5, 6, and 7 are basically going to be practice. All the stuff that we saw without using the entire page to do the problems because the templates really aren't that big and the math isn't really that long once you get the hang of these things. Question 5, you have a 40% off coupon for a TV. Okay, so 40% off or 40% less means that instead of paying 100%, you're going to be paying 100 minus 40%, which is 60%. So I'll take care of that at the beginning. If you pay $309 at the register, so they're really emphasizing that one right there. At the register, that's the end result amount that you paid. Then what was the original cost of the TV? Okay, so this is the 60% that you paid. So here's our template. 60% of the original price is going to be $309. Okay, and I like how this is, do the percent and then comparative value represent the same thing? Yeah, you pay 60% and you pay 309. So these two are the same thing. That means you're looking for the other number, the reference value. All right, now to set that up as an equation, we use our decimal form, which is 0.6. That would be multiplied by x, which is going to give you 309. So if you get the case where x is on this side here, you want to divide by that 0.6 to cancel it out, and then we go to a calculator to finish this off. $515. Put it out there, 515. All right, and that's all there really is to it once you get the hang of changing that percentage there. All right, 6. You and some friends have $48 to spend on dinner and tips. That's the total amount of money you get to spend. What is the maximum amount of dinner that can be so that you still have enough money to leave 20% tip? Okay, I think I read that a little bit odd, but that's fine. All right, so the $48 has to be the end result of what you're going to be paying here. I wrote down 48 must be the bill plus the 20% tip. All right, so whatever our base amount is, what it is before the tip is added on, that number plus the 20% is going to get us to $48. So this is going to be like a percent more than we want our bill. We want our final expenditure to be 20% more than the 100% price of the original bill for stuff here. So anyway, it gets you to 120% that you want to use. What you pay will be 20% more than the 100%. Okay, so 120% of some amount is going to end up being $48. I might not have worded all that as well as I wanted, but I think I kind of got to the general idea here. All right, so we don't know what it is, but multiplied by 1.2 should give us $48. We don't want to go over 48 because we can't afford it. So there's your setup. We're going to divide by 1.2, and 48 divided by 1.2 is 40. So you can spend $40, like you can ring up $40 and then still be able to do a 20% tip of $8 onto that. And of course you can go back and you can check, see how this makes sense at the end, find 20% of that, and then you should see that 20% is $8, so it brings you to that total of 48. All right, 7. They call this a challenge problem. I don't know, maybe just because we don't give you the template kind of outline to it. I didn't think it was too bad though. The number of stray cats currently cared for at a local animal shelter is down 15%. It is down 15%. That means that whatever it was the previous year, I want to make sure time frames I got it right. So the previous year to what it is now only appears to be 100 minus 15%, which is 85. Okay. So if there are currently 240 stray cats at the shelter, how many stray cats were there last year? So we don't know the reference value. We know the new value, which is representing 85% of the reference value. So 85% as the decimal form is 0.85. We don't know what it was last year, but if we were to multiply that number by 0.85, it results in the number of stray cats this year, which is 240. So still fitting our template here. You're still seeing the change in the percentages at the beginning. This ends up being a division problem. So we'll go ahead and divide 240 by 0.85, which is not going to turn out to be an exact number here, but I guess we'll go with 282. Most of these questions, they seem to set them up where we had nice solid numbers for it, but in reality, you know, like you may have had that number and then it turned out to be that number, because there's going to be whole cats. You're not going to get partials, and then they rounded the percentage change off to the 15. Last page of 3A part 2, as I will call it here, is more or less like a summary, and it gives you that practice on completing the blanks that we had seen at some of the ends of the previous problems. I don't remember what numbers they were, but all right, up at the top here, these I thought were a little bit tricky in how you're supposed to fill them in, but I think this is what we wanted to have. I didn't look up an answer key to it, but this is the idea. If the compared value, the end result number, is a percentage more than the reference value, then we should take 100% plus p% of the reference value. All right, so if you have a more than situation, you want to add it onto 100. Okay, if you have a less than situation, you want to subtract it from 100. Okay, and you want to do that stuff at the beginning so that you can then just use that percent of number, and by using a percent of number, then you can fit it to the template that we've been applying. All right, so let's see what we got here. Most of these are fill in the blanks. The area of Norway is 24% more than the area of Colorado. So Norway's area is blank percent of Colorado's. Well, if it's 24% more than, then you're going to add that on to 100%, which means that Norway's area is 124% of Colorado's area. Question number 9. The price of a generic medication is 9.4% less than the price of the name brand medication. So the price of the generic medication is blank percent of the name brand one. Okay, so you'll just subtract that from 100%, which is going to give you 90.6%. The generic medication is 90.6%, so less than 100, 90.6% of the name brand one. Question 10. Referring back to the other ones, what is the decimal form of the percent calculated in 8? That would be shifting the decimal 2 spots over. It's always going to be 2 spots over. So move over 2 and you're going to get 1.24. And now you can use that number for one of these types of statements where you say times the area. The area of Norway is 1.24 times the area of Colorado. 11 is going to go back to number 9. We'll just move that decimal 2 spots over and say 0.906, which means that the price of the generic medication is 0.906 times the name brand. Meaning you could take the name brand price, multiply it by this number, and it now tells you the generic medication number for it. All right, 12 and 13 says, putting it all together. All right, a store is having a 60% off sale, therefore the price of an item is blank times the original price. All right, so if it's 60% off, that means that you're going to pay 40%. But for that time statement, we want to move the decimal 2 spots over and call that 0.4. 13, when you buy a TV, you pay 8% sales tax in addition to the price of the TV. So you will pay blank times the price of the TV. Sales tax is getting added on, so it's going to be 108% that you pay 100 plus 8% as a decimal form. You move that forward and you get that, which I like this as, not that we're done with the entire section here, but to conclude this part of what we're talking about, because I do that when I go shopping, right? Let me go back to my beginning problem here, the one that I made up. I wanted to buy some shoes that were 20% off. I can multiply the 65 by 0.8 because that's the percentage I'll pay, and I think that turned out to be $52. But then that answer, I can also multiply by 1.0825. Sales tax in Texas is 8.25%. So if I know something's on sale, but I want to know exactly what it's going to be at the register with sales tax, you can just multiply those numbers together, and it'll give you the overall final cost. And I do that all the time when I go shopping, because sometimes they'll advertise like what the sale price is, so they'll tell you the 52, but they're never going to tell you what the cost is after tax. So that's one you can really easily do on your own. Any like type of stuff that you're buying, groceries you don't have to pay taxes on, by the way, but other type of merchandise you can just multiply by 1.0825, and that'll tell you exactly what it's going to cost with the taxes. Okay, part 3 of section 3A is going to be talking about how we describe a change in values as a percentage. That's mostly where this is going. The previous part, all of the problems seem to start off with these something is 40% more than, something is 30% less than. They tell you all these things. And what we're doing in this section is figuring out how do we actually get those numbers. If we knew the old value and the new value, how do we write it up as saying a percent change in something? All right, now in here, there's going to be 2 main things that we're looking at almost simultaneously. There's something that is going to be called absolute change, and there's something called relative change. The relative change is going to be all percentage stuff. That's the main thing here. Anytime you see the word relative, and that's true going on into other things that we'll do, we're going to talk about like graphs and diagrams and stuff. And if you see the word relative, it means percentages. Absolute is going to be like a true number thing here. In our case, it's going to be true number change, like the exact amount that it went up or down, not as a percentage type thing. Okay, so the beginning here, let's see, Lake Travis is historically low. In 2015, Lake Travis is historically low at 624 feet. Luckily, the lake increased by 62 feet the next year. What was the level in 2016? Okay, so you would just add on 62 feet to 624, and you should get 686. You should get that number. Okay, where we're gonna go. All right, an alternative way to describe this, we can say that between 2015 and 2016, the level of Lake Travis increased by about 9.9%. And what they want us to do is verify that that actually sounds right. Okay, so going back to what we did in part 2, if something increases by 9.9%, that means you're going to have 100 plus 9.9% of the value that we used to have, right? So we'd have 100 plus 9.9 for that. Okay, so then to apply that and to find out what the height changed from 624, what it changes to, you would multiply it by the decimal form of 109.9%. So move the decimal forward 2 spots, looks like this. And when you multiply those numbers, you get 685.7, which rounds to 686. Okay, so what we see here are 2 ways to describe going from 624 to 686. One of them tells you the exact number of feet that is changed by, and the other one's going to tell you a percent increase to it, which you'll probably think, man, that one's a whole lot more confusing. But the reality is we're going to need to know how to do things that speak in these terms. All right, now going back to how I described these at the beginning, the absolute is the normal, just how it's changed. The relative is talking about percentages. So when we said the 62 feet increase, that was absolute change. When we talk about the 9.9% change, that increase, then that's going to be what we refer to as relative change. That's what these 2 questions answer down here. Okay, now for the rest of this page, for the rest of this page, we're going to talk just about absolute change, not any percentages. So you're going to see the numbers are fairly straightforward. Absolute change is taking the compared value, the new value, and subtracting the reference value. Now that's important that it's going to be the new value minus the old value, because when you switch the order, it can, depending on the size of the numbers, you can get positive versus negative. Okay, and what we want to always do is look at the new value minus the old value. If the new value is bigger than the old value, you're going to come back with a positive number, and positive means increase. If the new value is less than the old value, so you subtract something greater, you're going to come back with a negative number, and that negative tells you that it's decreased. So it's important that we have them in the right order. All right, the prompt to this one, everyone loves a pay raise. Suppose that your salary increased from $30,000 to $32,500. What was the change between the starting salary and the salary after the raise? So if you just subtract those numbers, you get $2,500. Okay, this is what we call absolute change. That's how much it's changed by, not a percentage system. It's just a simple, straight subtraction problem. All right, so let's see here. Okay, now suppose that a recession hits and everyone at your work must take a pay cut. Okay, so now your money's going to go down. Your salary is going to drop from the $32,500 that you just got down to $29,000. Okay, even less than what it was before. So it drops down to $29,000. All right, let's figure out the absolute change. The reference value is going to be the $32,500. The new value, compared value, is going to be the $29,000. So when you subtract these, the $29,000 is first. The reference value is going to be second. So it's always going to be new minus old. Let's write that down. New minus old. All this is going to happen in the relative change stuff too. So you really want to get the concept of new minus old. Okay, so our new salary, the lower one, if you subtract your previously higher salary, you're going to get a difference of $3,500. But because of the way we subtract it to a negative $3,500, which is important because we know it's a reduction. And negative will refer to that. So when a salary increased, the absolute change was positive. When the salary decreased, it was negative. Okay. Again, one more time, it's very important that you're always thinking new value minus old value. Sometimes what we want to tell ourselves is that if we mix them up, well, we can always just add the sign or take away the sign if we need to. But when we transition into the relative change, it's going to be important that we do have these titled as new and old, and I'll try and elaborate when I get there. Let's see, 7, a practice problem. You bought a car for $15,500, and after 6 years, the car is worth that much. Okay, so the value has gone down. What is the absolute change in these? So you definitely want to subtract these. You should subtract them new minus old so that you come back with a negative value, a negative $6,800. Again, if you do these in the wrong order, as long as you understand that it's decreasing, you're able to bring in that negative, right? You don't want to leave that answer out or the negative out. I'm going to have to take away points because it's technically part of the problem. Okay, but getting back to, if you do them in the wrong order and then you just add the sign, though that's all right here, when we get to the relative change, that might cause a little bit of trouble for you. Okay, so for relative change, I'm going to talk about this right here first, and then I'll go back to the beginning and do that portion because it helps with this. All right, relative change is not much different than absolute change, except that we need to convert it into a decimal. Okay, so to do that, well, here's your template. You actually take the absolute value and then you divide it by your reference value. Okay, so wording might get a little bit confusing, but remember, reference value is the old number. Okay, so compared value is new, reference is old, reference is old. So though these words are technically the correct way to do it, I sometimes like to teach it this way. The absolute change, as I mentioned in the previous page, is the new minus the old, okay? But if you need to change the absolute change into relative change, you're going to divide that now by the reference value, and the reference value is the old number. So as I mentioned in the other one, it's important to know like the new and the old and to do it in that order, because if you move into relative change, whatever that second value is, that one has to be the denominator. You don't get the same answer if you put your compared value or your new value on the bottom. You got to make sure these are the same. And there isn't a quick fix. Like if you do it wrong, you can't just like change a sign or subtract a number or do something different. You've really just messed up the problem. So you really want to get this idea of new minus old divided by old for relative change there. All right, a couple problems to set things up. These are really exaggerated, and I thought they were crazy the first time I read them. All right, suppose that someone earns a salary of $100,000 and they receive a raise of $15. Is that a big raise? No. Compared to your $100,000, and I think that's the idea here is compared to, is what we're going to talk about. Compared to the $100,000, $15 is nothing. Great, we got $15, we'll take it, but we're not really going to notice it. Number 9, suppose that someone who earns hourly $10 receives a $15 raise. Yeah, that'd be a really big raise because they're getting paid more than twice what they were originally getting paid. So even though the absolute change is the same thing here, the way that it compares to the other value, which are relative change, it's going to be a totally different thing. Okay, so 10, referring back to the stuff that was up there, what is the compared to value of the raise? And 8 is the person who made a lot of money and they're just making a little bit more. So their compared to value is just going to be $15 greater than 100,000, $100,015. So do you expect the relative change to be big? Well, we know that it's not much of a change anyway, so no, it's barely going to be anything different. Okay, and then doing the calculation that we know for relative change, it's going to be the new minus the old. So if I take this number minus 100,000, it gives me my $15. That's also the absolute change. So there's that. And then you want to divide it by the original amount that he has. So divide that by 100,000, and it comes back as this number. Moving the decimal a couple spots to change it into a percentage, you're going to get less than 1%. Like way less than 1%. Okay, this is 15 thousandths of a percent. So it's a tiny, tiny amount. Okay, so for our other person who is making $10 an hour but is now making $25 an hour, you're going to get a really big relative change from that one. Okay, now let's look at the calculations. The absolute change is going to be $15, which matches the $15 absolute change that the other person had. The calculation is coming from the 25 minus the original 10, so new minus old. So that's going to give you 15. That you're then also going to divide by the old number, which is the 10. So we're looking at 15 divided by 10, not 15 divided by 100,000. So 15 divided by 10 is going to give you 1.5. Move that decimal over 2 spots to get your percentage, and we get 150%. Okay, so the other one is getting way, way, way less than 1% increase. while this person's getting 150% increase. So totally different thing here. So even though the absolute change can be the same, relative changes can tell a totally different story. All right, problem number 12, we're gonna fill in the blanks with positive or negative. Like absolute change, the relative change will be positive if the reference value increases and negative if the reference value decreases. Okay, personally, I think we could have added a little bit more wording to there. Maybe tossed in the words reference or compare to value, just so that you have it. But what they're saying is if the old value goes up, then your relative change is positive. If your old value is going to go down, so you get a lower compared to value, then it's going to be negative. But I think you probably got the idea from that. Okay, 13, this is going to take us back to the car problem that we looked at just for absolute change. The car was worth $15,500 and then it dropped down to $8,700. Okay, so we found the absolute change to be a negative $6,800. By just subtracting those two, you get this. Now you do need to subtract, if this is all about the right order, you have to subtract the new minus old. Okay, so I needed to take 8,700 and subtract the 15,500 to get the negative in that answer. If you do it the other way, you're still gonna get 6,800, but it's gonna be positive. Now, that problem was all right, and I mentioned at that time that you could just add the sign to it if you know it's decreasing, which is good. I mean, that tells me that you understand what's going on in the problem. Once you get to relative change, you got to be really careful about this, because if you're setting up the template exactly right, you're taking the new value minus the old value, then that old value is what's going to go in the bottom here. So really identifying new and old. The actual terms, of course, are reference value and comparative value, but I like to call them new and old. Okay, the newest value minus the oldest value divided by the oldest value is going to give you the right relative change. See, if you're subtracting these backwards and just adding your sign, by doing it backwards, you might accidentally divide by the 8,700 and then you just get a totally wrong answer. Okay, so just make sure you're really thinking new, old, all that stuff. All right, so the absolute change was negative $6,800. The relative change is negative 43.9%. That's what that calculates to. All right, 14 is going to have us fill in blanks, like interpreting what the numbers are with the right wording around them for sentences. Okay, so the first says the value of the car decreased by $6,800 or 43.9%. Okay, notice that neither of these numbers have negatives on there because the word decreased is already in the sentence for that. So the value of the car has decreased by that amount, or we could say that it's decreased by 43.9%. All right, next, the car is worth $8,700, or this part right here I thought was kind of tricky, and how it was, or 43.9% less now. Okay, so it's still the same thing here. It's just placed in a different sentence, like how it works in with the other words, I guess. Here they're saying that they are the same thing. These are not the same thing, but in the wording, it's become that value from taking away the 43.9% from it. Right, so for this page, problems 15 through 19, we're gonna look at just setting up the relative change problems and just doing the calculations. They do call this up here relative change or difference, because you could use that word like in there as a difference, but don't worry too much about that part there. Okay, 15, let's compare the price of a $50,000 Mercedes to the price of a $40,000 Lexus. Okay, now there are some important things within how you word stuff. Because we want to compare the Mercedes to the Lexus, that makes the Lexus the reference value. When you compare to something, it's a reference. So the difference that we have in this situation is that it's not a like a chronological, where I was always talking about new and old, new and old, new and old. Okay, but whatever you're comparing to, you can think of it sort of as like the old number, that's going to be your reference value. Okay, so the difference between these is going to be $10,000. Right, just subtracting them. Therefore, we say that the Mercedes costs $10,000 more than the Lexus. All that makes sense. What we want to do now is change it into a percentage type problem. Okay, so there's your template. It's compared to value minus reference divided by reference. And in this problem, the compared to value, I mean, it straight up says it here. Let's compare 50,000 to that one. So this would be the 50,000, and both of these are going to be the 40,000. Okay, so we already subtracted them and found the 10,000, so I left it there. But we're going to divide the 10,000 by the 40,000, which is going to give you 0.25 or 25%. So we say that the Mercedes costs 25% more than the Lexus. The key thing about this is making sure that you have the right reference value that goes in the bottom. Because if your reference value is the Mercedes, you're going to come back with 20%, which is different. So you really want to just get it from the sentence, which is like the newer one that we're comparing to something else. What else do we got here? Notice that the compared value costs more money, so the relative difference is positive. Yeah, it was well, we got that from the 10,000, that Mercedes was more expensive, so that would have been a positive. So the relative difference would have been positive. If the compared to value is less than the reference value, then you should get negative. So if we wanted to compare the Lexus to the Mercedes, we would get a negative number. By the way, it would not be a negative 25% though, because when you switch the compared and the reference value, your denominator would also change. And you're going to see that at the very end of this page. So I won't dig into that one too deep there. All right, 17, 2009 life expectancy in Canada, which is that number of years, is blank percent greater than 2009 life expectancy of Russia. Okay, so what that means when we say greater than blah, 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 Russia, that means that Russia is going to be your reference value. So you're going to see I took the 65.9 years, placed it here and there as the reference value, and I put Canada's life expectancy and placed it there. So just trying to figure out where all the numbers go. That's the main thing to the problem. After that, you just subtract these two. You divide, and it should be that number with the decimal in the front. I'll show you that one. So 81.2 minus 65.9 gives you 15.3. We divide that by 65.9. You get 0.232. You can see the number there, so moving the decimal over will give us the 23.29%. All right, 18 and 19, these are really good problems because they show you the changing in how we deal with our reference value. All right, 18, the median age of first marriage in the US, women, 25.9 is blank percent less than the median age of marriage of men, 27 years. So the men is going to be the reference value because we're saying less than, and that's comparing to this other number. Okay, so the men are going to end up in these two places here, okay, and the women is going to be the compared to value. So we would subtract the 27.5 from the 25.9. That's going to give you a negative number. I should probably show you at least that part. 25.9 minus 27.5. So you can get a negative number here that we need to divide by 27.5, which gives us that number. Okay, so the negative is going to be the less part that's already included in there, and then moving the decimal over 2 spots is going to give us 5.8. So it's 5.8% less than the median age. So this was comparing the women's age to the men's age, okay? In 19, what we do is we switch the order of everything. We look at comparing the men's age to the women's age. So same numbers, everything's the same, but in the wording here, it changes what is the compared to, or what's the compared value to the reference value. The reference value is now the women, so women end up in both of these spots and the men's here. So on the top, when you calculate, you're still going to get a difference of 1.6, but in the last one, right, it was negative 1.6. The difference here is still going to be 1.6, but positive, not much of a difference. But because we changed the reference value, the denominator is a totally different number than what this one is. So your answer is not going to be, if this is 5.8%, it's not still going to be 5.8% here, because changing that denominator, and you get that, so about 6.2%. Okay, and there's a really important thing that's like right here, that when you compare one direction, like we could talk about the Mercedes and the Lexus, If we compare the Mercedes to the Lexus, we see that one as being 25% greater. But if you go the other way, and maybe try it out a little while here, if you compare the Lexus to the Mercedes, it's actually going to be 20% less. Not 25%, it's going to be 20% less. And you might want to check that one out. So depending on what your reference value is, the numbers are actually just different, and that's an important thing to understand at some point here. Okay, for our final thing here, which I'm going to call section 3A4, this one's a very short one, it's only one page here. What we're going to do is mess with your head just a little bit. We're going to do the same, pretty much the same stuff we did with relative change, but we're going to do it using percentages to begin. So not having like raw or normal numbers, we're using percentages within the calculations, and we are going to call it percentages of percentages. Okay, so let's see what this would look like. The math is all the same. You just got to get used to the idea that you can have a percentage within the problems. Where are we at? All right, suppose that a bank increases its mortgage interest rate from 3% to 4%. Okay, so the numbers that you're being told are percentages. They have to be, for this kind of a problem. There aren't any other numbers you can use to talk about mortgage rates except as percentages. Okay, question A. The absolute change from 3% to 4% is 1%. It has gone up by 1%. Okay? And now new terminology here. We can describe that as 1 percentage point. So be looking out for these words right there, percentage point. All right, so percentage point is really just like the absolute change if we're talking about things that begin in percentages. All right, now the relative change in interest, that's going to be your new minus old over old. Okay, so it changed from 3 to 4, so your new value is 4. The old value is 3, right? And subtract it, you got 1, we already know that. But you want to divide by the old interest rate, which was 3. Okay, so we're going to end up dividing 1 by 3, which gives you 0.3 repeating. So that means that the bank raised its interest rate by 33%. So kind of take that for a second here. The percentage points have increased by 1 from 3% to 4%, but the relative change, how it feels compared to the other value, is that it's gone up by 33%, right? It's gone up by 1/3 of that percentage to get up to this one. So a little bit odd stuff here, but calculations are all generally the same. Question 2. Assume that 40% of voters in County A are Republicans. If the percentage of voters registered as Republicans in County B is 25 percentage points greater than County A, what percentage of registered voters in County B are Republicans? Okay, percentage points is the same thing as the absolute change. So that would be simply taking what we had in County A, 40%, and then adding on 25%, which gets you to 65%. That's what that is, percentage points. The next part of it, it says if the percentage of registered voters as Republicans County B is 25% higher than County A, what would be the percentage of registered voters in County B? Okay, and this goes all the way back to the beginning, stuff that we did here. You're not going to add 25% on because it's not a percentage point, but we have this percent higher, which means you want to add it on to 100%, call it 1.25, and then multiply that by 40, which will get you to 50%. Okay, so with two things that sound somewhat the same, but understanding the differences that this is like just a straight adding, subtracting done. This is going to be multiplying by a percentage. All right, and last, question number 3. Consider the following statement taken from newspaper. The rate of smoking among 8th grade girls rose 44% to an all-time high of 10.4%. Okay, it sounds kind of weird here, right? The rate of smoking among 8th grade girls rose 44% to an all-time high of that one. It's like, well, wait a minute, we rose 44%, but we're only at 10.4%. It's because this is like a relative change that we had going on from what it used to be, okay? The 10.4% is gonna be like your normal type numbers, your raw numbers, and then this is the actual percentage in the problem that we've got, okay? But it did raise by 44%. So we're going to think of this as 100% plus 44, which is going to give you 1.44. We don't know the original amount of smokers, but we know the final result, which is 10.4 technically percent. That would be there. Okay, so it fits that template from way back at the beginning. You're going to divide the 10.4 by 1.44. And figure out that it used to be 7.22%. The rate among 8th grade girls rose by blank percentage points. All right, so for that, we'll have to subtract these two numbers. 10.4, we'll actually just call it 7.2. Minus 7.2 will give us 3.2. Okay, the questions on this page, just because the uses of, because it is percentages of percentages, you might need to look at these a couple times and just sort of let that process where all that comes from.